Hello there, this is a PWM motor speed controller. Let's see how to build one. You can see that the motor speed increases when I turn the potentiometer. I had few components lying around, so I'm building one. This is going to be really interesting, so watch till the end. And yeah, do subscribe. Let's understand the circuit here. This is basically an astable multivibrator, which generates PWM, pulse width modulation. In a pulse width modulation, it has 1 and zeros. When it's 1, the motor gets power, and when it's 0, the motor doesn't. So to control the speed of the motor, we are controlling the delay in the signal, like for how much time this should be on and for how much time it should be off. The more time it's on, the more longer time the motor gets power. So by this, the motor speed is controlled. How are we doing this, you may ask? It's because of this potentiometer. From pin 3, it gets power. From the pin 3, it goes through this diode. This diode then charges the capacitor here. When the capacitor is completely charged, it discharges through this diode. Say this is diode 2 and this is diode 1. From the diode 2, it goes through this resistor. If you notice, there are 2 sections of resistor here because of the potentiometer. So it discharges through this resistor. And by varying the resistor, we can adjust the speed of how fast the capacitor is charging and discharging. By that way, we can increase or decrease the delays in the PWM signal. Now, by the timer itself, you cannot turn on the motor because it can't provide more power. That's why we use an N-channel MOSFET, but your circuit could be a little bit wobby-sobby, so you can use a transistor too. But I don't want that, so I'm using an N-channel MOSFET here. And you must add a diode and a capacitor in parallel. A diode because it cancels out a back EMF. Now, back EMF is not bad, it's very bad for your circuit or the components. And a capacitor to filter out this. Yeah, you know it. That's how it all works.